240.3d of the National Electrical Code states that conductors, including neutral conductors, must have an ampacity of not less than the branch circuit ampere rating. This crucial requirement ensures that the conductors in a circuit are appropriately sized to safely handle the full current load protected by the circuit breaker or fuse. A switch leg, which is a conductor carrying power from the circuit breaker or fuse to the switch controlling a load, becomes relevant in this context. Consider a scenario where a 14-gauge conductor serves as a switch leg connected to a 12-gauge, 20-amp circuit. According to 240.3d, the 14-gauge conductor, typically having a lower ampacity than that required for a 20-amp circuit, would not be permitted for this application. This is because the conductor's ampacity must match or exceed the circuit breaker's rating. 240.3e introduces an exception to the rule specified in 240.3d, particularly for certain types of loads. Specifically, 240.3e allows conductors for branch circuits or other loads specified in Article 210, Part Roman 3, to have an ampacity as detailed in that part of the code. Article 210, Part Roman 3, addresses general lighting loads. Section 210.19 of the 2002 National Electrical Code specifies the ampacity of conductors for lighting loads, stipulating that it shall not be less than the load on the branch circuit as determined by Section 210.11. General lighting loads fall under the umbrella of other loads within Article 210, Part Roman 3. Therefore, 240.3e potentially allows for the use of a 14-gauge conductor as a switch leg on a 20-amp circuit, provided that the actual load on the circuit remains below 14 amps. It's essential to understand that if the load on the 20-amp circuit equals or exceeds 14 amps, using a 14-gauge conductor as a switch leg would violate the stipulations of 240.3d. To ensure compliance with the National Electrical Code, it is important to verify both the ampacity of the conductors and the actual load on the circuit before deciding whether a 14-gauge conductor is permissible as a switch leg in a specific installation. The crucial determination hinges on whether the load remains within the ampacity limits of the 14-gauge conductor, as dictated by the exception provided in 240.3e in conjunction with Article 210. The interaction between these sections of the NEC is critical for safe and code-compliant electrical installations, particularly in residential settings where lighting circuits are common. It is recommended that you understand the relevant sections of the National Electrical Code and the correct application of these codes for electrical safety. Firstly, you must correctly interpret 240.3d. This section emphasizes the fundamental principle that all conductors within a circuit, including the neutral conductor, must possess an ampacity rating at least equal to the overcurrent protection device protecting the circuit. This ensures that the conductor can safely carry the maximum current the circuit is designed to handle without overheating and posing a fire hazard. Secondly, the correct interpretation of 240.3e is needed. This section offers an exception to the general rule established in 240.3d. It specifically addresses branch circuits serving certain types of loads detailed in Article 210, Part Roman 3. This exception permits conductors to be sized according to the specific requirements outlined in Article 210, Part Roman 3, which often allows for smaller conductors than those dictated by the overcurrent protection device alone. Thirdly, you must review 210.19 in the 2002 National Electrical Code. This section provides specific guidelines for determining the minimum ampacity of conductors used in lighting circuits. It states that the conductor ampacity must not be less than the load in the branch circuit, as calculated per section 210.11. This means that the conductor must be adequately sized to handle the anticipated lighting load, accounting for factors such as the number and type of light fixtures connected to the circuit. Then, understand the proper application to switch legs. A switch leg, the conductor running from the switch to the lighting fixture, is an integral part of the lighting circuit. When applying the National Electrical Code, one must determine whether the switch leg conductors can be sized based on the exception in 240.3e or must adhere to the general rule in 240.3d. The key factor is whether the lighting load qualifies as one of the other loads specified in Article 210, Part Roman 3. consider the load calculations. To determine whether the exception in 240.3e can be applied, it is necessary to calculate the actual load on the lighting circuit. This involves summing up the wattage of all lighting fixtures connected to the circuit and converting it to amperage using the circuit voltage. If the calculated load is less than the ampacity of the 14-gauge conductor, the exception may be applicable. Evaluate compliance based on load. Once the load calculation is complete, compare the result to the ampacity of the 14-gauge conductor and the rating of the overcurrent protection device. If the load is less than both the conductor ampacity and the overcurrent protection rating, using the 14-gauge conductor as a switch leg may be permissible. However, if the load exceeds either of these values, a larger conductor must be used to ensure code compliance. Consult the authority having jurisdiction. The authority having jurisdiction plays a crucial role in interpreting and enforcing the National Electrical Code. When in doubt about the proper application of these sections, it is always advisable to consult the authority having jurisdiction for clarification and guidance. Their interpretation may vary based on local codes and amendments. Review examples of compliance scenarios. To further illustrate the application of these principles, consider a few examples of compliant and non-compliant scenarios. For example, a residential lighting circuit protected by a 20-amp breaker and serving a total lighting load of 10 amps could potentially use a 14-gauge conductor as a switch leg, provided that all other requirements of the National Electrical Code are met. Review examples of non-compliant scenarios. In contrast, a commercial lighting circuit protected by a 20-amp breaker and serving a total lighting load of 18 amps would not be permitted to use a 14-gauge conductor as a switch leg. In this case, a larger conductor with an ampacity rating of at least 20 amps would be required. Ensure proper documentation and record keeping. Accurate documentation and record keeping are essential for demonstrating compliance with the National Electrical Code. Maintain detailed records of load calculations, conductor ampacity ratings, and overcurrent protection device ratings for all electrical circuits. This documentation will be invaluable during inspections and audits. Provide ongoing training and education. The National Electrical Code is constantly evolving, with updates and revisions released every 3 years. To ensure continued compliance, it is essential to provide ongoing training and education for electricians and other electrical professionals. This will help them stay up to date on the latest code requirements and best practices. Use approved materials and equipment. When installing electrical wiring and equipment, it is essential to use only materials and equipment that have been approved by a recognized testing laboratory, such as Underwriters Laboratories. Approved materials and equipment have been tested to meet safety standards and are more likely to perform reliably over time. Follow manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical wiring and equipment. The manufacturer's instructions provide detailed guidance on proper installation techniques and safety precautions. Failure to follow these instructions could result in unsafe conditions or equipment failure. Conduct thorough inspections. After completing an electrical installation, it is essential to conduct a thorough inspection to ensure that all work has been performed in accordance with the National Electrical Code and other applicable standards. The inspection should include visual checks of wiring connections, equipment grounding, and overcurrent protection devices. Take corrective action. If any deficiencies are identified during the inspection, take corrective action immediately to address the issues. This may involve correcting wiring errors, replacing damaged equipment, or upgrading overcurrent protection devices. By following these guidelines and best practices, one can ensure compliance with the National Electrical Code and create safe and reliable electrical installations. Adherence to these principles will help prevent electrical hazards, protect property, and save lives. Also, review the specific language of the NEC sections reference. Pay close attention to the exact wording of 240.3d, 240.3e, and 210.19 refer to understand the nuances of each requirement. Be aware of any local amendments or interpretations that may modify the application of these sections. It is important to consult with local authorities to determine if there are any specific requirements in your jurisdiction. Understand the purpose and intent of the code requirements. In addition to understanding the specific language of the code, it is helpful to understand the purpose and intent behind the requirements. This can provide a deeper understanding of the underlying safety principles and help one make informed decisions about electrical installations. The NEC is designed to protect people and property from electrical hazards. Its requirements are based on years of experience and research, and they are constantly updated to reflect the latest technological advancements and safety concerns. When interpreting and applying the NEC, it is important to consider the overall goal of electrical safety. Understand the concept of ampacity. Ampacity is the current carrying capacity of a conductor. It is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor is determined by its size, material, insulation type, and installation conditions. The National Electrical Code provides tables that list the ampacity of various conductors under different conditions. These tables are used to select the appropriate size conductor for a given circuit. The ampacity of a conductor must be greater than or equal to the calculated load in the circuit. Understand the role of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. An overload occurs when a circuit carries more current than it is designed to handle. A short circuit occurs when there is a direct connection between two conductors that have a different voltage potential. Overcurrent protection devices trip or blow when the current exceeds their rating. This interrupts the flow of current and prevents the conductors from overheating and causing a fire. The rating of the overcurrent protection device must be less than or equal to the ampacity of the conductor it is protecting. Consider the entire circuit when selecting conductors. When selecting conductors for a circuit, it is important to consider the entire circuit, not just the portion that is visible or easily accessible. This includes the conductors in the walls, ceilings, and floors, as well as the conductors in the equipment and appliances connected to the circuit. All conductors in a circuit must be properly sized and protected to ensure safety and reliability. Seek expert advice when needed. Electrical installations can be complex and challenging, and it is not always easy to understand and apply the National Electrical Code correctly. If you are unsure about any aspect of an electrical installation, it is always best to seek expert advice from a qualified electrician or electrical engineer. These professionals have the knowledge and experience to ensure that the installation is safe, compliant, and reliable. Regularly inspect and maintain electrical systems. Electrical systems should be regularly inspected and maintained to ensure that they are in good working order. This includes checking wiring connections, equipment grounding, and overcurrent protection devices. Any problems that are identified should be corrected promptly to prevent electrical hazards. Regular maintenance can also extend the life of electrical equipment and appliances. Stay informed about changes to the NEC. The National Electrical Code is updated every 3 years, and it is important to stay informed about any changes that may affect electrical installations. The National Fire Protection Association offers training courses and publications that can help you stay up to date on the latest code requirements. By following these guidelines and best practices, one can ensure that electrical installations are safe, compliant, and reliable. Electrical safety is everyone's responsibility, and it is important to take the necessary steps to protect yourself, your family, and your property from electrical hazards.